Alright, our group did area of a kite. And this is also known as Theorem 6.24, which can be found in your packet, your green packet. And typically, kites look like what my assistant is drawing. They cross, showing the diagonals. And then kites get intricate. They have very, very animalistic shapes to them, such as dragons. So I'm going to draw a dragon on this kite. And then it's got two back legs and thorns on those. And then, oh, the dragon tail. Here we go. Thorny dragon tail. And then the dragon head. It's got a very aggressive look to them. And then the dragon thorns. So that is a dragon. For this next part, we will be talking about the definitions of a kite. The area of a kite is 1/2 the product of the lengths of its diagonals. This formula being A equals half of the diagonals. So A equals 1/2 D1 D2. And for this next part, we shall be showing an example of our pre-drawn kite there. And the first diagonal will be 12. And then on the other side, 8, and then 13, and then those two sides, those two left sides will be congruent, and then the other sides congruent. And so basically what you want to start out with is you want to add the two sides together. So, oh, you also want to use the Pythagorean theorem, sorry. So 13 squared is 169, and then 12 squared is 144. You subtract those and you get 25. You square root that, you get 5, and that shows the top, or the C, of the Pythagorean theorem, which is 5, and that means that the other side has to be 5. So that whole diagonal is 10. So 12 plus 8 equals 20, and then you times it by the other diagonal, which is 10, and you get 200. And then since it's the two diagonals divided by 2, you get 100. And that is how you use area of a kite. And this next slide is going to show you the summary. And this consists of the formula, which, as I remind you, is A equals 1/2 of D1 and D2 times D2, excuse me. And for me, I think this needs full concentration, because if you mess up somewhere, you'll mess the whole problem up. So if you just follow these simple rules, I believe that you can achieve in finding the area of a kite. Exclamation point.